z less than or equal to 0, a plane wave with h is equal to 10 cos 10 power 8 t minus beta z ax cap milliampere per meter is incident normally on a lossless medium epsilon is equal to 2 epsilon naught, mu is equal to 8 mu naught. In region z greater than or equal to 0. Determine the reflected wave HR and transmitted wave HT. So this is another kind of problem. The solution to this problem is this is z is equal to 0 region. In free space z less than or equal to 0. A plane wave with h something is incident normally. So this is z less than or equal to 0 region. This is z greater than 0 region. Z less than 0 region, z greater than or equal to 0 region. So here the field is incident normally h. So the given thing is hi. This is free space. So this is a lossless medium. Lossless medium with properties epsilon is equal to 2 epsilon naught, mu is equal to 8 mu naught. Then they are asking for what is the reflected wave HR and what is the transmitted wave HT. Therefore HI is given thing, HI is equal to 10 cos 10 power 8 t minus beta z ax cap here. This beta is equal to omega by c. Beta is equal to omega by c, which is in free space. HR I want. I have to calculate first of all HR, what is the reflected thing. So we know HR by HI is equal to eta 1 minus eta 2 by eta 1 plus eta 2, where eta is intrinsic impedance, eta 1 is intrinsic impedance in medium 1, eta 2 is intrinsic impedance in medium 2. Eta 1 is free space, so eta 1 is equal to I know 120 pi, whereas eta 2 is nothing but square root of mu naught to mu r, that is a lossless medium, by epsilon naught epsilon r. So that is equal to 120 pi into square root of mu r by epsilon r. Mu r is nothing but 8. Mu r is nothing but 8 by epsilon r is nothing but 2. So that is nothing but 240 pi. That is nothing but 2 eta 1 eta 2 is equal to 2 eta 1. Therefore, HR by HI is equal to eta 1 as it is minus eta 2 is 2 eta 1 by eta 1 plus 2 eta 1 minus eta 1 by 3 eta 1 minus 1 by 3 HR by HI. Therefore, HR is equal to minus HI by 3. HR is equal to minus HI by 3. Now, what happens? It is equal to, what is HI? Minus 10 by 3 cos 10 power 8 minus beta z AX milliampere per meter. Here the important thing is HI, the incident field. The incident field is in, what is the direction? The incident field is in positive z direction. So HR is opposite to, the reflected field is opposite to incident field. So HR must be minus z direction. Therefore, HR is equal to minus 10 by 3 cos 10 power 8 t plus beta z instead of minus beta z, because here the reflected wave direction is opposite to HI. Now, if you calculate beta value, beta is equal to omega by c, because HR and HI are in both free space only. So, omega is equal to 10 power 8 by c is 3 into 10 power 8. That is nothing but 1 by 3. So, substitute beta as 1 by 3. So, this is the HR field. Now, we have to calculate HT, transmitted wave. I know that HT by HI equal to 2 eta 1 by eta 1 plus eta 2. 2 eta 1 by eta 1 plus eta 2. So here eta 2 is equal to, already we calculated 2 eta 1. So that is equal to 2 eta 1 by eta 1 plus 2 eta 1. So that is equal to 2 by 3. Therefore, HT is equal to 2 by 3 into HI. So that is equal to 2 by 3 into, what is HI value? 10 cos 10 power 8 t minus beta z AX cap milliampere per meter. Since this is z is equal to 0 plane, HI is in this direction, HT is also in the same direction. So here we will keep 10 power 8 t minus beta z only. But beta here, beta is equal to omega by c dash. We have to calculate c dash. C dash is equal to 1 by square root of mu naught mu r epsilon naught epsilon r value. So that is nothing but 3 into 10 power 8 by square root of epsilon r into mu r 16. That is 3 into 10 power 8 by 4. 3 into 10 power 8 by 4. That is c dash. Therefore, what is beta value? Beta is equal to omega 10 power 8 by c dash. 3 into 10 power 8 by 4. That is nothing but 4 by 3. Beta is equal to 4 by 3. Therefore, ht is equal to 20 by 3 cos 10 power 8t minus beta z ax cap milliampere per meter. So like this we can calculate transmitted field. Here the important thing is this direction. Since HI and HT, incident and transmitted are in the same direction, we are keeping it as minus beta z only. In the previous case, HR is opposite to HI, that's why we are keeping it as plus beta z. So like this we can calculate similarly EI, ER and ET also we can calculate. We can calculate EI. How we can calculate EI? Because HI is given. So EI by HI is equal to, both incident are in same, that is eta 1. So therefore EI is equal to eta 1 into HI. Both EI and HI are in the same direction. So like this, once EI is known, then we can calculate ER, we can calculate ET. So this type of problems are very important. Next topic is reflection of a plane wave at oblique incidence. Reflection of a plane wave at oblique incidence. Suppose a interface is like this. This is an interface separating two medias. This is the normal to the interface. Or if you consider this as interface, this is normal to the interface, whatever it may be. Suppose a wave is incident at an angle theta I to the normal of the interface, then it will reflect with some angle. This is medium 1, this is medium 2. Medium 1, medium 2. So a wave is incident at an angle of theta I to the normal of the interface. Then it is reflected with an angle theta R and transmitted with an angle theta T. So this is reflected and this is transmitted or reflected. So the reflected is into the same medium, the transmitted one is into another medium. So all the angles are with respect to the normal of the interface only. This is a wave is reflected with an angle theta R, and generally we can call it also as a refracted wave. This wave, transmitted wave, is also known as refracted wave with an angle theta T. Then according to, we know Snell's law of refraction, theta I is equal to theta R. According to Snell's law of refraction, eta 1 sin theta I is equal to eta 2 sin theta t. Eta 1 sin theta I is equal to eta 2 sin theta t, where eta 1 is intrinsic impedance in medium 1, eta 2 is intrinsic impedance in medium 2. Therefore sin theta I by sin theta t is equal to eta 2 by eta 1. Eta 2 by eta 1. Eta 2 is square root of, eta 2 is equal to square root of mu naught mu 2 by epsilon naught epsilon 2. Eta 1 is equal to square root of mu naught epsilon mu naught mu 1 by epsilon naught epsilon 1. So this is also equal to square root of eta 2 by eta 1. How we can write this? This is here, this is not eta 1, this is n1, this is n2, where n1 and n2 are refractive indexes. Please correct this one, n2 by n1. This is n2 by n1 according to Snell's law, where n2 is given by c into square root of mu 2 epsilon 2, n1 is given by c into square root of mu 1 epsilon 1. Mu 1 epsilon 1. Therefore, sin theta I by sin theta is equal to n2 by n1. We will get mu 2 epsilon 2 by mu 1 epsilon 1. Therefore, this is very important formula. Sin theta I by sin theta t is equal to square root of mu 2 epsilon 2 by mu 1 epsilon 1 according to Snell's law. At a particular angle of incidence, there is no refraction. There is no refraction, that is, the entire wave will reflect back. The entire wave will reflect back. That particular angle is called as that a particular angle of incidence is called as critical angle. That the particular angle of incidence is called as critical angle, which is given by theta c equal to sin inverse square root of epsilon 2 by epsilon 1. So keep in mind this formula. Theta c is equal to sin inverse epsilon 2 by epsilon 1. We will work out a problem based on this concept. Problem is a uniform plane wave in air impinges at 45-degree angle on a lossless dielectric material with dielectric constant epsilon r. The transmitted wave propagates in a 30-degree direction with respect to the normal. The value of epsilon r is option A 1.5, option B square root of 1.5, option C 2, option D square root of 2. This kind of problems are important. The solution to this problem is, suppose this is the interface, this is a normal to the interface. So a uniform plane wave in air impinges at 45 degrees angle on a lossless dielectric. So this is a dielectric interface. Dielectric interface, which is incidenting at an angle of 45 degrees. It is incident at an angle of 45 degrees. With respect to normal, we have to consider with respect to normal. This is epsilon r. This is a free space, air. Air means nothing but free space. The transmitted wave propagates at an angle 30 degrees with respect to normal. Then what is the value of epsilon r? So here, according to Snell's law, sin theta I by sin theta t is equal to square root of mu 2 epsilon 2 mu 1 epsilon 1. Mu 1 epsilon 1. So this is equal to sin incidence is 45 by sin 30 is equal to mu 2 epsilon 2 means this is mu naught epsilon r by mu naught epsilon naught only because of free space. So that is equal to square root of epsilon r only. So sin 45 means 1 by root 2. Sin 30 1 by 2. So into 2 is equal to square root of epsilon r. Implies epsilon r is equal to 4 by 2. 4 by 2 is nothing but 2. Therefore, what is the epsilon r value? Epsilon r is equal to 2. Epsilon r is equal to 2. So option C is correct. Option C is correct. When the incidence angle is at 45 degrees, obviously the reflected is also 45 degrees. That's why we are using Snell's law for this case. So this kind of problems we can expect in the examination. The only thing is you have to apply the formula properly.